Hello all, welcome to SMB306. Hope you're having an amazing reinvent and continuing the learning journey and also interacting with the fellow builders who have come all across the world to this amazing event. I, as a solutions architect, work and interact and learn from the customers like you on a daily basis across the industries, across the personas. It could be individual developers, architects, key business stakeholders, the decision makers, etc. And in all those interactions which I have are surrounded by the business ideas. It could be a new business idea or a new application, new service which you want to build for your business, want to create those new revenue streams or the value streams within the business. Although the technical level of these discussions vary between the personas, but the focus is always around how do you take those business ideas, quickly build a solution, and deliver it to your end customers, whether it is internal customer or external customer, doesn't matter, but take those ideas and quickly, efficiently, and rapidly deliver to your end customer, thus delivering the business satisfaction and the business growth. They both go hand in hand, as you know. So that is exactly what we're going to cover in this session, where we'll look at how do you take those business ideas, those product ideas which you have, from their inception or the concept phase to the production or to your customer as seamlessly as possible by doing rapid prototyping on AWS. Although we are working backwards from the SMB's key technical priorities, challenges in this session, but this session is very much applicable to whoever is interested in rapid prototyping or building those solutions quickly and rapidly on AWS. So with that, my name is Narendra Gaka. I'm one of the senior solutions architect with AWS. I'm based in UK. My interaction, I've been at AWS for the past 3 years, and I've been continuously working, as I was saying, that with the small and medium businesses within the UK. I'm also joined by Sonal Panda. She is a senior solutions architect based in US SMB, and she works with the SMB customers as well. She'll be doing demo as we go progress towards this session. Let's start with the agenda and what we're going to cover and how do we structure or see this session. We'll start with the customers or SMB customers. What are your priorities are when, and also we'll look at what are the challenges which you face when it comes to the technology, and we'll see the prototyping, the phases within the prototyping, what are the key stages involved, what are the focus areas within one of those stages are, and how do you go about leveraging some of the AWS services to help you with prototyping. We'll bring it all together where we'll pick a use case and try to build a solution from scratch and see things in action so that you can all know that how the prototyping can be done rapidly on AWS. Towards the end, we have collected all the necessary resources for you to get started within your organization so that you can start building these prototypes, what we are talking about. And we'll also summarize and look at the key takeaways for this session. Let's start with understanding the SMB landscape. So according to a recent study which was done by IDC on worldwide SMB market profile, in no particular order, these are some of the key business priorities when SMB customers face. So according to that survey, almost 35% of the customers responded that you would want to grow revenue within the organizations by creating those new value streams or creating of those innovative services and products within the business. While attracting, also 33% of the customers also mentioned that you would want to attract new customers and retaining the existing customer base to enhance the business, while keeping an eye on the cost and reduce the total cost of ownership when you want to build those services, all while driving an innovation and efficiency within the businesses, and also leverage the data-driven decision-making within the organization. So these are the business priorities according to the study. But let's look at some of the challenges which the SMB businesses face. So, again, in no particular order, according to the same IDC study, SME businesses face challenges around the limited IT staff. It could be a combination of both the number of people within the organization and also the skill set. There is a wide gap within the skill set. There are outdated skill sets as well. And almost 50% of the respondents, according to the study, have mentioned that there is a challenge about when you build this new solution, security of those solutions is one of the major concerns. You want to build those solutions rapidly, however, making sure that the security elements are taken care of it is a challenge. So let's look at how to address that as well. Again, there are challenges around the budget. There are limited IT budget, so that when you're trying to build something new, there are budget constraints. And there are challenges around the siloed application and data as well. Okay, so far we have looked at the key business priorities and the challenges. But when you talk about creating those new products and services faster to the market, create those new value streams or the business streams within the SMB customers, for you to go there, if you double the number of experiments within you do per year, you're going to double the inventiveness within your organization. So this is a quote from Jeff Bezos, who is the founder and executive chair of Amazon. So you basically double the number of experiments you do every year so that you create those new value streams or the business, grow your business. And how you do it is by prototyping it or trying out new things within your business and see if those actually add value. Let's look at the key business or key stages within the prototyping. Let's start by the launch of a new product or a service, or it could be an enhancement to an existing application also. So when we talk about new product or service, generally any application will have a combination of both functional requirement, which talk about what is the end user problem you're trying to solve, what is the user experience it's going to look like, what is the value add you're trying to deliver, part of this prototype, which talks about the functional requirements. But there's also a set of non-functional requirements. It could be the cost, security, performance, latency, and so on and so forth. There are a set of non-functional requirements. So once you define both this functional and non-functional requirement, you go with doing a demo. So when we talk about demo, these are, if you look at the x-axis, we talk about the time it takes for you to develop this demo. On the y-axis, we have the scope or the completeness of the vision or completeness of the product. We have to balance between both of them. But in a demo phase, you're trying to prove a narrow set of technology, that this particular technology will actually meet your requirement. And it need not necessarily have a business context completely, because you're trying to prove a technology side rather than the business side in a demo phase. So once you complete the demo and you're happy with that particular technology, it's going to work for the requirement you have, you start with the POC phase, right? The proof of concept phase, where you add the missing business context within that particular demo. And you prove that this actually is going to work with the technology outcome you started with. And you often, because these are so quick in timeline, you generally combine both together as a one iteration. And once the POC is fine, you're happy with it, you basically build a prototype where again add a full business benefits framework on top of that particular POC which you have developed. And you keep an eye on the business outcomes in this particular phase, that the prototype is actually adding value to your business. And once the prototype is done, you basically release that prototype to a small set of users, may it be internal, external, all while keeping an eye on the key business metrics, performance, otherwise technology, non-technology. Could be anecdotal feedback from your customers or a combination of all of this to measure the success of this prototype. Right? So once the pilot is done, obviously you do a broad market launch where we roll it out to all the production users which you have for that particular pilot. Again, keeping an eye on the business metrics to see how successful that particular prototype is, how is the users interacting with that system, capture the feedback, and again, the whole point of this particular prototyping is that you want to go back to your drawing board, again, iterate as quickly as possible so that you constantly deliver value or improve upon the service. Right, so far we have talked about the prototyping journey, what are the key stages involved, how do you take it to production, etc. But no matter how simple or how complex an IT system is, it has two parts to the puzzle. One is the infrastructure side of things, where your application actually will go run on it. It could be compute, networking, and other part of it. And the other part is the business logic part, where you actually develop or solve the end user problem. That is the business logic part. So it is a combination of both of these elements. But for our prototyping, you need to be able to rapidly address both of these parts of the puzzle. But let's start with the infrastructure side of things on AWS. How do you go about solve this particular problem? That is exactly where AWS serverless or serverless services come in the picture, which helps you rapidly address the infrastructure side of things so that you can leverage these building blocks and prototype quickly. So what is serverless? So basically, serverless helps you focus on what matters to your end customer, which is where you solve the end customer problem, which is the business logic, those APIs. Whereas we at AWS take care of the underlying operational and management side of things, which is the messaging, orchestrated, the compute, the networking, storage aspects, so that you, with the limited IT staff which SMBs have, can focus on what actually matters to your end customers and how do you go about resolving or solving those unique problems within your business. Why serverless? Because there is no infrastructure for you to manage. You can take those building blocks and quickly build a solution on top. It will automatically scale, addressing the requirement when it comes to the scalability of your requirement. Especially given we've looked at the phases of the POC, of the prototype, it goes to the demo, POC, pilot, production, so on. So you only pay for the value you get out of that particular solution. And it's leveraging the building blocks from AWS, so it is highly available and secure as well. AWS offers the widest portfolio of serverless services for running any application possible. So you have various different building blocks. You have a primitives such as compute, containers, or event buses. For example, you can run a function by leveraging AWS Lambda function, where it takes care of the underlying compute resources for you. Or maybe you want to run a Docker image. You can leverage AWS Fargate for you to run those container images in Amazon Elastic Container Services or Amazon Elastic Kubernetes Services, etc. So you also have various event buses such as Amazon Event Bridge, etc. So you also have, especially when you need to run a relational database or non-relational, you have options for it as well, like Amazon Aurora Serverless, or if you want to go with the NoSQL key value store, you have Amazon Document DB, which offers up to a millisecond latency. So you have various different services with which you can build any application or service possible there. Okay, one of the challenges which we talked about with unique to SMBs is the total cost of ownership. This is according to a Deloitte report. The customers who chose AWS serverless services can reduce their total cost of ownership by up to 68%. The reason it is that you only pay for the resources you use. Again, it is available and secure. You automatically scale, especially with the SMB customers. We've looked at all the stages. According to the stage, you don't want a production level infrastructure or the level of the scale for your non-critical workloads or non-production workloads. But for production, as you're rolling out, your environment would automatically scale and meet those end customer requirements. And you reduce the overall maintenance because there's no infrastructure for you to manage or provision because it's already taken care. Especially given the rapid prototyping we are talking about, serverless services increase the agility with which you can take those applications to production faster. So the customers can reduce their development time by up to 54% with serverless services, according to a study done by S&P. And one more key thing, especially when talking about the serverless services, is that your developers, with that limited time they have, can focus on writing the code and can also leverage the built-in capability of these services, and thus end up having to write less code so that they can focus on solving those critical problems. And again, continuously improve and iterate upon those prototypes over a period of time. Okay, fine. So we have talked about the serverless services, the spectrum of the services for you to pick and choose from. But how do you go about developing that prototype, developing that serverless application? So especially when you're getting started, you can basically log into AWS console, try things out, and build an application. That's absolutely fine. However, we would recommend you to think about infrastructure as a code framework or infrastructure as a code, which is basically a repeatable way for you to consistently spin up the environments across different stages like dev, test, production, staging, etc. So you have a consistent way of reproducing that environment. You can leverage various different services out there. So you have AWS Serverless Application Model, which is a AWS SAM, which is an open source framework with which you can spin up the resources within AWS. You also have AWS CDK or Cloud Development Kit, which is again an open source framework with which your developers or builders can, in their familiar programming language, declare or create the entire application, both the application and also the infrastructure components within. You also have other solutions such as serverless framework or HashiCorp Terraform, various other tools. So you can pick and choose which works best for your business. Or especially when you are getting started with knowing these serverless services, how do you use them, etc., you can leverage AWS Infrastructure Composer, with which you can visually compose and configure these serverless services by dragging and dropping them in your visual canvas, and also connecting various different services to create that event-driven architectures, all while it is generating that infrastructure as a code for you to deploy. So it's basically giving you a deployment-ready infrastructure as a code. You can leverage AWS SAM to basically deploy that architecture so that you can reduce the learning curve. Okay, so we have looked at serverless services, talked about how do you go about creating that infrastructure as a code using SAM, CDK, and so forth. But when given a particular business requirement, let's say a product or service idea which you have, you still have to pick and choose the combination of the services which would best fit that requirement which you have. It could be a storage, compute, networking, containers, so on and so forth. So you have to basically pick and choose the services, connect them, and build an architecture. And also, there is a challenge, or how do you go about writing that efficient code to solve that business use case or business requirement which you have. So there's still a part to the puzzle. So that is where you can leverage Amazon Q Developer to address those requirements. So it helps you with the entire software development life cycle, helps your developers, IT professional, architects to interact. They can interact with the Q Developer and write, debug, test, and create those applications way faster. So you can, in a natural language, in a conversation style, interact with the Q Developer to ask questions about a particular service, to know what a particular best practices is for that service, how do they go about using them, so on and so forth. We'll see that in a second. Amazon Q is available wherever you interact with AWS, wherever you do your work. It is available within the IDEs, AWS console, the documentation. You can also leverage the chatbots in Slack or Microsoft Teams, etc. Let's look at in which areas Amazon Q Developer can help you. With exploration and plan, you can ask in a natural language For example, how do you go about building a web application on AWS? And it's going to come up based on the wealth of AWS experience, on the best practices, knowledge bases it has. It's going to come up with the advice on it. And you would be able to create applications much faster and plan those architectures using QDeveloper. So you would be able to use QDeveloper to generate the code, explain the code which you might have already have, especially if you are new to a particular project. You would be able to use Q to explain that code and customize your code based on your natural language inputs in your IDE. So you would be able to extend the QDeveloper capabilities by connecting your private repositories, which may have information on your code base, your coding practices, private libraries, etc. So that the suggestions which it's going to give you would be taking into consideration what your APIs, what your libraries, etc. already have, so that you can generate the new code faster, which is according to your existing code bases. So especially when you're new to a particular project and you want to know and learn about a particular project code base, you would be able to ask question about particular code base, and you would be able to learn or create the new documentation feature which was announced in a keynote. So you would be able to write documentation and help understand the internal code base with a QDeveloper. Okay, one of the features is again QDeveloper agents helps you with rapid prototyping, where you can write and implement the entire application features by giving it a natural language prompt. And in an interactive phase, it's going to break down the prompt into multiple iterative statements, and it's going to generate the code, the features, the unit tests, security, and all that. And one of the key challenges with the software development lifecycle is again on writing those unit tests or checks, etc. for your application. And also to know, one of the key challenges we talked about with SMB customers is how do you know if your application is secure? So you'll be able to test your application, test your code base if it has any vulnerabilities when it comes to security, and leverage QDeveloper. It not only gives you a report of where the vulnerabilities exist, but also it helps you remediate those by giving you just suggestions on how do you go about quickly and efficiently resolve those vulnerabilities. So you can scan an entire project for security vulnerabilities as well. Yeah, as announced in the keynote earlier as well. So you would be able to operate your applications when deployed on AWS. You can use QDeveloper to diagnose and troubleshoot those issues, where it scans your architecture, your CloudWatch logs, your performance metrics, your CloudTrial logs, etc., to see what exactly is changed within architecture, so that you would be quickly able to find out the root cause of an issue. It could be a network issue, it could be a IAM or a permissions issue. So you'd be able to quickly know where a particular root cause of an issue is and how do you go about remediating it as well. It's not only give you the root cause, but also how do you go about quickly resolving them as well. Okay, so far we have talked about the serverless services, QDeveloper. Let's now bring it all together, right? So we'll pick a use case, we'll try to build something from scratch and see things in an action of how do you use a visual infrastructure composer, the serverless services, interact with the QDeveloper, what sort of recommendations does it give, and we'll see things in action. And I'll now hand it over to Sonal so that she'll be able to take you through all of this.
Hi everyone, my name is Sonal Panda and I'm a Senior Solutions Architect at AWS. I support SMB customers in application modernization, focusing on serverless architectures and building generative AI applications to drive innovation and efficiency. At AWS, we work backwards from the customer requirements. So let's start by picking a real use case of our building the demo today. Let's imagine you're running an e-commerce app with thousands of products, and you plan to add more products to your portfolio as you enter into new markets. Traditionally, you would need a team working round the clock, spending hours and days maintaining this product list. But what if you could leverage technology to automate this process with as much accuracy as possible? In this demo, I will be leveraging AI to demonstrate the rapid prototyping capabilities available on AWS, which can help small businesses that do not have sufficient staff, saving time and effort, making the whole process easier and faster, so you can focus on what really matters to you, serving your customers and expanding your brand. So for this use case, there are two requirements. The first requirement is you need to have a storage location where you can copy these product images. And then you need the AI model to process these images, extract the product specifications, and you want these specifications to be stored into the database. This flow is asynchronous in nature. And the second requirement is you need to have an API exposed for the end users for retrieving the product specifications from the database. And you can integrate this API either with a web app, mobile app, or it could be as simple as an API call. So with these requirements, let's get started. So I have this Visual Studio Code IDE open here. This is my empty workspace. I will start by adding a new folder to my workspace. I'll call this folder Demo Project. I have AWS Toolkit extension installed in my VS Code IDE that gave me access to AWS Infrastructure Composer, and I also have Amazon Q Developer plugin installed. I will be leveraging both the services for creating the demo today. So let's start by asking Q the architecture recommendation for both of our requirements. So I'll quickly open this Q chat window here, and I have this prompt ready which I'll just copy and paste, asking Q to provide me the architecture guidance where I need to build an application using serverless services for storing images into a storage location and have the processing triggered. I want to use large language model, and my database schema is going to be flexible. And I need to expose an API for retrieving the product specifications. So I'll just simply copy and paste this prompt into the Q chat window. It might take a few seconds for Q to come up with the recommendation here. Yeah, so if I scroll back up, for my first requirement of image storage and processing, Q is recommending to use S3 for storing the product images. And for the image processing, the guidance is to use Lambda. And for image analysis piece where I need to have my product specifications extracted from the images, it's recommending to use Bedrock with large language model. And on the database side, the guidance is to use the DynamoDB because in my prompt, I mentioned that I need to have my flexible schema. And for my second requirement for API access, the guidance is from Q is to use API gateway for creating the RESTful API, and for the backend processing, use Lambda function. So with these recommendations, let's get started. So I'll just quickly go back to the folder which I created just now and create a new file called template.yaml. This is AWS Infrastructure as a Code template. And on the top right side, there is a link to open Infrastructure Composer in VS Code. So I'll just simply open Infrastructure Composer here in my IDE. And if you see here on the right hand side, this empty space is the canvas where I'm going to drag and drop the resources and create my workflow. And on the left hand side, we have the list of resources. We have standard IAC resources. These are the standard CloudFormation resources. And then we have enhanced components. These are the one or more like CloudFormation resources, combination of one or more CloudFormation resources. So let's say, for example, if I drag and drop a Lambda function into my canvas, It will not only create the Lambda function, but it will also create the log group and the IAM policy required by the Lambda function into the SAM template. So let's start creating a workflow. So I'll open this Q window here and start following the recommendations and start building my workflow here. So for my first requirement, Q recommended us to use S3 for storage. I'm going to search for S3 in my resource list and simply do a drag and drop into my canvas. If I come back to the template file which I created just now, so I started with an empty file and now I see this infrastructure composer has already created the code for us. And not only that, it is also following AWS best practice of encryption at rest, encryption in transit, and blocking public access by default. So for image processing piece, I'm going to search for Lambda function as recommended by Q and put it into my canvas. And then for the database, I'm going to look for DynamoDB and add it to my canvas. So I'll just close this window so we have little space here for setting up our environment. Now if you notice here, right, each one of these resource cards have two ports, one port on the left and one port on the right. These ports are used for creating the integration between our different AWS services, and our requirement is like the moment I copy these product images to S3 bucket, I want this Lambda function to get triggered so it can process these images, and finally we need to have these results stored into the database. So we need to create the integration between S3 bucket and Lambda function and DynamoDB. So I'll start by connecting this port on the S3 bucket to the Lambda function. So before I do that, just notice one thing here, right? The moment I highlighted this port on the S3 bucket side, it also highlighted the port on the Lambda function. So that tells me that this integration is supported. So I'll simply go ahead and drag and drop and create the integration between S3 bucket and Lambda function. But if I try to connect S3 bucket with DynamoDB, I'm going to get an error because there is no direct integration available between these two services. So just by looking at the visual, I can very easily identify what services like I can integrate together, stitch my services and create my architecture. So if I open the configuration that got generated just by connecting S3 with a Lambda function, so infrastructure composer has already created the logic in my SAM template to trigger the Lambda function on S3 object create event. Now let me go ahead and connect this Lambda function with DynamoDB. And looking at the configuration here, by connecting these two resources, the configuration that we see here is like there are environment variables created for accessing the DynamoDB table, and also it has created a DynamoDB CRUD policy, create, read, update, delete policy, providing necessary access to Lambda function. And you can refer these environment variables for accessing the DynamoDB table in the Lambda function instead of hard coding the table name. Now let's go ahead and update some of the configuration here. So I'm going to call this bucket image bucket and save this setup. And let's call this Lambda function image handler. I'm going to use Java as my runtime here, so I'll just select Java here. And there are a few more configurations down here, right? You can update the memory, the timeout, concurrency, but I'm just going to go with defaults for this prototype. You can also go directly to the template.yaml file and update the configurations there as well. For DynamoDB, let's give it a name. I'm going to call this as product specs. And I want to define product ID as my partition key. And save this setup. So this completes one part of my requirement, right? So the moment I copy the images to S3 bucket, this object create event will be triggered. That will trigger the Lambda function, and I will have the logic in the Lambda function to retrieve the image from S3 bucket, invoke Bedrock with large language model, providing it the instructions to extract the product specifications. I will be using Anthropic Claude 3 model for this demo. And finally, once the response is received from Bedrock, this Lambda function will store the results into DynamoDB table with product ID as a partition key. Now let's go back to the queue recommendations for our second requirement. For the API layer, Q recommended us to use API gateway and Lambda for backend processing. So I'll search for API gateway in my resource list and simply do a drag and drop here. And then Lambda function. Now for this API to work, I need to create integration between API gateway and Lambda function, right? When the call to API is made, we want this Lambda function to get triggered, and we'll have the logic in the Lambda function to connect to DynamoDB, retrieve the product list and pass it back in response to the API gateway. So we need to establish integration between API gateway and Lambda function. So I'll just simply go ahead and connect these two resources. And if you go back to the SAM template, you will see, it has already added the code for Lambda proxy integration with API gateway. And likewise, I'm going to connect this Lambda function with DynamoDB, giving it the necessary access for connecting to DynamoDB and retrieving the product list. Let's update some of the configuration here. I'm going to call this API product API and save this setup here. And let's define this Lambda function as product handler. And if you see here, it already selected Java as my runtime based on my previous selection. So I'll just go ahead and save this setup. Let's arrange this flow. I need to do one more thing here, right? For this image handler function, to access images from S3 bucket, I need to provide it the necessary permissions. Along with that, you need to have access to Bedrock invoke model API. So I'll just go ahead and create a managed policy and assign that managed policy to this image handler Lambda function. So just dragging and dropping this managed policy resource card here, and I can call this policy Lambda policy. I already have this policy document available in another window, so I'll just simply do a copy paste. So I took help from Q developer, so I gave Q developer my requirements that I need to have a policy created with S3 access and Bedrock invoke model, and I had this. I got this policy instead of me spending time figuring it out. The configuration, I was able to get this policy with the help of Q developer. So I'll just go ahead and save this configuration here. Now I need to associate this policy with the image handler Lambda function. I'm going to go to the template.yaml file and look for my image handler function. And if I scroll back further down in my policy section, I'm just going to add a reference to this Lambda, to this managed policy here. Okay, so this completes one part of the puzzle. Like as Naren mentioned, anytime we build an application, we need to address two parts of the puzzle. The first part is the infrastructure, and the second part is the business logic. So right now we addressed the infrastructure part. Basically, just by doing a simple drag and drop using infrastructure composer, I'm able to create the SAM template, and I can quickly trigger the SAM build and deploy this setup into my AWS environment. And imagine if you have to do this all by yourself, it would take good amount of time creating the template yourself. Just by doing a simple drag and drop and updating some of the configuration, my template is ready. So what I'll do is I'll start the SAM sync process, which is the powerful SAM CLI feature for syncing any local changes to your AWS environment. So it will validate your SAM template, it will trigger the SAM build and deploy. I'll open a terminal window here and trigger SAM sync. Let's give it a stack name. I'm going to call this as demo stack. And I'm going to deploy this to US East 1 region. Now this might take a few minutes. So while this is running, I'm going to use another window and show you the the code generation part with the help of Q developer. Like as we discussed, we need to address the second part of the puzzle, which is the business logic in the Lambda function. So I have the prompts ready for both the Lambda functions, and we can see the code generation part using Q. So this is my empty Java class. So I have this comment here where I'm instructing Q to create a Lambda function that queries the DynamoDB table for the product list, and I'm just giving the list of attributes. And finally, this function needs to return the product list in JSON format to the API gateway. So I'll just simply hit the enter button, waiting for Q to come up with the recommendations. Second, let me just make sure I have my Q connection. I need to authenticate again. 1 second. So I'm good here, so I'll just go back. Yeah, so I'm just going to hit the tab button and accept these changes. So based on the initial comments I added instructing Q for creating the Lambda function, I see it has come up with some code providing the implementation. And then you can keep refining this code, right? This is just a starting point. You can keep adding the comment and keep getting the recommendations from Q till you have your final implementation ready for testing. I also have another prompt ready for the image handler Lambda function. So I'm giving it the step-by-step instructions, asking it to create a Lambda function. For processing the image, I'm sharing the system prompt and the user prompt for the large language model, asking it to extract the product specification like product name, category, brand, etc. And also telling it to use product ID as the partition key. So just simply copying pasting this prompt here, which I have it ready in the Q chat window. And let's see the response from Q. This might take a few seconds, but once we are done with this piece, I'm going to show you the working version of this demo. So I have this demo already up and running. I can show you things in action end to end. I'll push some images from my local environment to S3 bucket, and we'll see the output in DynamoDB, and we'll also invoke the API using API gateway. So Q is coming back with the code here. So here it has already imported the necessary classes which it needs for the Lambda function. It is initializing S3 client, Bedrock client, DynamoDB, and here in the handler implementation, it is getting the image from S3 bucket, preparing and invoking the Bedrock API, and then finally storing the results in DynamoDB. For each one of these steps, it has created a separate method providing implementation. So if I scroll further down, you see that there are like separate methods with the implementation, and it has also shared the necessary dependencies which we need to set up for this Lambda function to work. I was able to finish the logic for both the Lambda function in a few minutes. If I had to just do it all by myself, it would have taken hours. So like I took majority of the code provided by Q to build this demo end to end. Now let me share some of the images I have in my local environment, which I'm going to push to the S3 bucket. So these are some of the images from Amazon Basics brand available on Amazon website. And if you see here, each one of these images, there is some information about the product category, name, brand, etc. So I have given the instructions to the large language model to extract all these attributes and send it back to me in response, and that's what we are going to store into the DynamoDB. So let's quickly, copy these images from the local environment. I'm just going to trigger S3 copy command and copy these images to my S3 bucket. Okay, so my images are copied. I'm going to go back to my browser window, and I have this S3 bucket window open here. I'll just refresh my screen. And there are 7 images which are copied here, and this is the timestamp in the Eastern time zone. Now at this point, right, so the moment I copied these images to S3 bucket, it would have triggered the S3 object create event, and that would have triggered the Lambda function. And at this time, I expect to see results in my DynamoDB table for all these 7 images which I have pushed to the S3 bucket. I have this DynamoDB table open here in another window, so I'll just quickly run a table scan. And I see there are 7 items created here for the 7 images which I copied to the S3 bucket. So let's open one of the item here. So if you remember, I defined a product ID as my partition key for the table, and then there are some attributes like brand, category, description, features. These are the instructions I gave to large language model for extracting the information from the image. So this is my output here for the images I push to S3 bucket. So this completes one part of the flow, which is image processing. So let's look at the second part, which is the API piece, right? So I have this API gateway window open here, and this is my API deployed. So you can either directly test this API from API Gateway Management Console, or you can simply copy this URL and use a third-party tool like Postman and test this API. So I have this Postman window open here. I'll just simply copy and paste this URL here and trigger this API. So this is my response coming back. From DynamoDB, if you see, it has the list of products in JSON format with all the attributes I was looking for. So this completes end-to-end demo. And if I go back and check the SAM process, okay, I think there is something went wrong here. Yeah, but I was expecting this to run, but it shouldn't take a lot of time, right? So coming back, sorry. Okay. Oh yes, so I think there is a syntax error here. Thanks Naren for that. So I think I just missed to add the exclamation mark here for adding the reference here. Yeah, so I'll just save this setup. Thank you Naren. And I'm just going to trigger this one more time. Okay. So while this is running, let me switch back to the presentation. So what next? This is just a sample prototype which I have created just now, right? You can add more functionality to this prototype. You can create a web front end using Amplify and integrate that with your API, or you can use Cognito to create the authentication piece. You can add exception handling. You can add logging to make this production ready. I encourage you to look at step functions and see if you can create an orchestration using multiple AWS services, taking the benefit of inbuilt exception handling and retry logic, and making your workflows run smoothly and reliably. I highly encourage to take this demo as a starting point and expand it to one of your use cases and see how you can leverage it to take the advantage of the features which are available in Infrastructure Composer, Queue Developer that can help you create your infrastructure as a code quickly and let you generate the code quickly. We have collected all the necessary resources for you to get started with AWS Serverless Services, Amazon Queue Developer, AWS Infrastructure Composer. There is also a working version of this demo up and running. So please go ahead and scan this QR code to get started. So here are some of the key takeaways from our session today. Fine, right? Here are some of the key takeaways from our session today. Given the unique challenges and priorities of SMB segment, rapid prototyping on AWS can help SMBs to innovate faster, leverage AWS serverless services to deliver value to your customers, address technology challenges, get the benefit of inbuilt security, scalability and high availability provided by its serverless services, and improve operational efficiency by eliminating infrastructure management, reduce cost with pay-as-you-go pricing model, use AWS Infrastructure Composer, MSNQ Developer to quickly shape your idea and bring them to market. Iterate quickly and repeatedly to improve your solution over time. Use agile iterative approach, create your prototype and get the feedback, refine your ideas. With that, I would like to thank everyone for attending our session today. Please take a moment to complete the survey. Your feedback is very important for us. You can reach out to us on social media for further updates and more information. Thanks again.
Thank you so much for your time. Thank you.